Let's look at a couple of examples now that involve finding the sign of delta G given the sign of delta S and delta H. So we're given a reaction here and we're told whether it's exothermic or endothermic. This one is endothermic. Our first mission here, predict the sign of delta S. And what we'll look at here is, first of all, we know that there's a relationship between entropy of gases, ions in solutions, liquids and solids. Gases the most, ions in solution are second, then liquids and then solids. Please go back to the entropy mini lecture for more information on that one. Alright, going back to our problem, we have to figure out what the sign of delta S is going to be on the reaction. And what we do is we see that we've got gases here, and the solid is not going to play a part because gases have far more entropy than solids do. But we do see that we have 12 molecules of gas on the product side and only 8 on the reactant side. So if we go take a look at our next equation, we see that delta S naught is going to equal the sum of entropies on the products minus the sum of entropies on the reactant side. And since we've got more entropy on the product side, we've got more molecules of gas on that side than we have on the reactant side, what that's going to tell us is that delta S is going to be positive. So I'll write positive underneath here. Now, looking at also at the reaction, we're told that the reaction is endothermic. Endothermic means delta H is going to be positive as well. Now, since temperature is always positive, what we're looking at is a situation where we're going to subtract a positive value from a positive value. Now, it turns out that if temperature is large, then this positive value will also be large, which means delta G will be negative. So at high temperatures, delta G naught is negative. And the reaction is spontaneous. At low temperature, and we could use 0 as an example if we wanted to, at low temperature we're going to end up with a positive value of delta G. Delta G is positive, and that would be non-spontaneous. So in this case we're looking at a variation in temperature. A variation in spontaneity in accordance with the temperature. High temperature, reaction spontaneous because delta G is negative. At low temperature, delta G is positive, so the reaction will be non-spontaneous. Alright, we'll get rid of that and we'll go on to the next example. Alright, let's look at this one. This one has a solid on one side and then aqueous ions on the other. And what I want you to see is that we have 3 aqueous ions and 1 solid. Since aqueous ions have more entropy than solids do, then we can predict that the sign of delta S here again will be positive. It will be for the same reason, because we have more entropy on the product side than we do the reactant side. We're going to end up with a positive value of delta S. A big number minus a small number is going to be a positive value. Alright, so we figured out that delta S is positive. We also know that delta H is going to be negative, and we know that because we're told that the reaction is exothermic. So again, delta G equals delta H, and the delta H is a negative value. minus a positive value. And we figured out delta H is negative, delta S is positive, and if you look at that, you'll see that that value will always be negative, regardless of the temperature. So delta G naught, always negative, reaction always spontaneous. Okay, so we can go back to the slides here, and what I want to point out is that the best wording, for example, for the first one is here. You can see it using this equation. It can be seen that since the reaction is endothermic, delta H is positive, delta S is positive, the sign of delta G naught will be positive at low temperatures and negative at high temperatures, and then linking that to the non-spontaneous at low temperatures and spontaneous at higher temperatures. So that was for the first one. Now for the second one, we can say the same thing using the equation delta G equals delta H minus T delta S. It can be seen the reaction is exothermic, delta H naught is negative, delta S naught is positive, and the sign of delta G will be negative at all temperatures, and reaction will be spontaneous at all temperatures. When I use the words as written here, I'm really just talking about this forward direction for the arrow, because you could also say the reverse about the reverse reaction, but we're always interested in just what's going on with the forward reaction.